Okay, what's up, people? This is GRE Bombs. We're in Bomb 16, and here we have a quick question. It's a fill in the box type of question. Let's take a look at what it says. It says a square and an equilateral triangle have sides of length 6. What is the ratio of the area of the triangle to the area of the square? All right, so I start drawing some of the information given. Okay, let's say this is the square that they're talking about. They say that it's of length 6. Since it's a square, all the sides are the same. Have here 90 degrees. And an equilateral triangle is a triangle where all the sides are the same length. And because all the sides are the same length, all of the angles are the same. So what are the angles in equilateral triangle? Well, if the sum of the interior angles is 180 and all of them are the same, that is, all of these angles here are the same, that's the same as adding them all up. That's 180, and then we just divide them by 3 to get the value, and it's 60 degrees. So all of these angles here are 60 degrees. Alright, so we want to find the area, the ratio of the area of the triangle to the area of the square. So I'm going to write it here. So the ratio would be area of triangle. I'm going to, draw an image of a triangle over area of square. Let's see, area of square. There we go. All right, so the area of the square is base times height. This is my base, this is my height. 6 times 6, that's what I write here. That's the bottom. We already know the bottom right away. And for the area of this triangle, we know it's going to be 1/2 times the base. Let's say this here is my base. It's going to be 6. And now, which is, I think it's the part of the problem that's really testing you, is finding that height. What is going to be the height of this triangle? And not only knowing the height, but also you want to do it pretty fast. You don't want to do a lot of calculations. You want to use information that you know about triangles to find it easily without having to calculate a lot. All right, so we're going to drop our height from up here down to the base. Now, in the case of equilateral triangles and isosceles triangles, the base dropping here from the top will create a 90-degree angle here at the bottom. So that means we formed a 90-degree triangle. And because this is already 60 degrees and this is 90, this is one of those special right triangles. The ones that are 60, 30, 90. So for example, this is 60, this here is 30. And we know that the proportions of the sides in a 30, 60, 90 triangle are 1 for the side opposite to the 30 degrees. It's going to be radical 3 for the side opposite to 60. It's going to be 2 for the hypotenuse. All right, so we go back here. We have here our 90-degree, our right triangle, 30, 60 right triangle. Since the hypotenuse is 6 and the proportions are 1, 2, and rad 3, we know because this is 60, this is 90, that this is 30 degrees, that this side here, this side right here must be half of the hypotenuse, must be 3. Why? Because here in the proportions, you see that 1 is half of 2. So that same proportion must be maintained in our triangle. And then the remaining side, which is the height, which is what we're trying to find, it's going to be 3 radical 3. We literally just multiply this side by radical 3 because the side opposite to 60 degrees has a proportion of radical 3 to 1 in the 30, 60, 90 triangle. Since this was 3, this has to be 3 radical 3. And that's it. We got our height, which is 3 radical 3. Again, and I think this is the most important part. You see that we didn't use Pythagorean theorem. We didn't calculate anything. We literally used basically the information that we know about 30 and 60, 90 triangles and their relative proportions to literally find the height without having to do any computation. And that's extremely important in GRE. You don't want to start number chugging because it creates room for mistakes. It wastes time. If you maybe miscomputed something, you have to do the whole computation again. So that's a complete no-no. And now here, solving this ratio, we can start simplifying. Since there's a 6 up here and a 6 down here, we can cancel it. We have now what? We have, well, this 1/2 really becomes 2 times 6 in the bottom. And in the top, we're left with 3 radical 3. 6 times 2 is 12. We have 3 radical 3 in the top. And then this 3 and this 12 cancel to 1 and 4. And we have radical 3 over 4. And that's the ratio. That's the area of the triangle divided by the area of the square. And our answer is going to be radical 3 over 4. And that's the solution to this question. Again, the meat and potatoes of this question was literally finding the height of the equilateral triangle. Again, extremely important. You do not want to go into a GRE test without knowing the 1 radical 3, 2, i.e. 30, 60, 90 right triangle. You definitely want to know that. You want to know the idea of the proportions. You see here with this 1, we literally just multiplied this by 3 and got that 3. We got this 2 and multiplied it by 3 and got 6. And therefore the height must be this radical 3 times 3. And that's my height. Once I know the height, I plugged it into here, which is the area of the triangle, 1/2 base times height. In the bottom, we have base times height of the area of the square. And then now it's just reducing into a simplified form of the fraction. Again, that was a GRE Bomb 16. I'll see you guys in Bomb 17. Take it easy, like, subscribe, write questions about certain type, write recommendations of questions that you would like me to solve. And I'll catch you guys later. Take it easy. Bye.